Well, we got cut off there a moment, so we're picking up on question number 9. We had just found f composed with g of x. We replaced g of x with 1 over x, and then we went to f and replaced that variable with 1 over x, and 3 times 1 over x gave us a 3 over x under the radical. And I was saying that I remember rationalizing in the first assignment, but if you view an example of when you're typing in your answer, this is the format that they want. So we'll just stop right there. That'll save us some work. Let's go in the other direction now. G composed with f of x. What's the inside function? F of x. So on the outside we have that g, and on the inside we have that square root of 3x. So this is saying, go to g, and wherever you see a variable, what am I going to write down there in place of that x? Okay, so we're going to have 1 over, and we're going to replace that x with the black square root of 3x for my final answer. Any questions there? Let's see. So, for f composed with g of x, we had the square root of 3 over x. And for g composed with f, y'all tell me, what do you think I'm going to click on first? Remember what we're trying to enter is 1 over the square root of 3x. So I agree. I would click that fraction bar first, and then I have a 1 on the top, and on the bottom I have square root of 3x. Any questions there? The next 2 questions are trying to get you ready for inverse functions, which we'll probably be seeing next week. Let me write this problem down. Number 10. It says for f of x equals 5x minus 2, and g of x equals 1/5 times x plus 2. They want us to find f composed with g of x and g composed with f of x. That's what we've been doing the last few problems. Oh, and then they ask us this question. Determine whether f composed with g of x is equal to g composed with f of x. Well, under most circumstances, why are they even asking us that? We know that under normal circumstances, what's that answer going to be? Will f composed with g of x equal g composed with f of x? No, it usually doesn't. The mere fact that they're asking us this question makes me think maybe it will. Let's find out. We'll start off with f composed with g of x. So, f is on the outside. F is on the outside. G of x is on the inside. And we know g of x is 1/5 times x plus 2. G of x is on the inside. F is on the outside. This says go to your function f, and wherever you see a variable, in place of that black x that I'm pointing at right there, I'm going to replace that x with 1/5 times x plus 2. So that's a 5. Replace the x with 1/5 times x plus 2. I have something else stuck on there. What is it? The minus 2. 5. Replace the x with the stuff in the parentheses. We still have that minus 2. Remember, you multiply from left to right. And so once you start multiplying, I think the fraction makes this problem look messy, but as soon as you start multiplying from left to right, 5 times 1/5. I think the 5's cancel out, don't they? The only thing we have to distribute over the x plus 2 is what? 1. That's not going to change anything. That's just going to stay in x plus 2. And we still have what? That minus 2 stuck on there. Oh, that works out nicely. The 2 minus 2 subtracts out, leaving us with just the variable x. Now, let's go in the opposite direction. G composed with f. That means G is on the outside, and on the inside we have f of x, which is 5x minus 2. G is on the outside, the inside function is f of x, which we know is 5x minus 2. So this says, go to your function g, and wherever you see a variable, in place of that variable right there, what am I going to write? 5x minus 2. So I have a 1/5, 1/5. I'm going to replace that variable with the black 5x minus 2 that I have in parentheses there. And I think this is going to work out very nicely. First of all, what's about to happen to the constant terms? Negative 2 plus 2. Yeah, so they're gone. We have a 1/5 times 5x. What's about to happen to the 5's? Leaving us with just 1 times x is x. So both compositions reduced to x, f composed with g of x reduced to x, and g composed with f of x reduced to x. So yes, they are equal. Functions like this, whose compositions reduce to x and are equal, are said to be inverse functions, and we'll be defining inverse functions, as I said, I think it's next week. And I'll remind you, y'all remember numbers 10 and 11 on with composition? And y'all will say, yes, y'all remember them. And I'll say, oh, good. And are they equal in this case? Yes, they are. One more. Number 11. Let me write, oh, this looks sort of bad. I see a radical up there. F of x is equal to the cube root of 5x plus 6. And g of x is equal to 1/5 x cubed minus 6/5. I'm just copying this down. And it's the same three questions. Find f composed with g, g composed with f. Are they equal? Let me switch over. Let me make sure I didn't miscopy the problem here on my paper. Yes. Here it goes, right there. Part A, f composed with g. Which function's my outside function? F is on the outside. I'm usually asking what's my inside function, but this time I tricked you. I asked for the outside function first. Then now the inside function is, there's the g of x. And we know what g of x is. They gave it to us. It's 1/5 x cubed minus 6/5. There, I'll zoom in a little bit. So this says go to f, and wherever you see a variable, replace it with the stuff in the parentheses. So I have that cube root. I have 5 times the stuff. What else do I have underneath this radical? The plus 6. And I have the 1/5 x cubed minus 6/5. I think something nice is about to happen with the fractions. We have that 5 in front of these parentheses here. What do we have to do with that 5 to get rid of the parentheses? So we'll distribute that 5, and look at that. 5 times 1/5 is just 1, so we have 1x cubed minus, what happens with the 5 times the 6/5? What's going to happen 5 times 6/5? The 5's cancel, leaving you just a 6 for x cubed minus 6, and we still have the plus 6. I think terms are about to start disappearing. What's going to happen to the constant terms? Negative 6 plus 6. Gone, okay. The cube root of x cubed. What happens when you take the cube root of x cubed? It just falls off, leaving you with just an x. So f composed with g of x reduced to x. Any questions there? Any questions on my manipulations? Now, g composed with f of x. What's on the outside? Which function's on the outside? G is on the outside. And on the inside we have f of x, which is a cube root of 5x plus 6. So this says go to function g, and wherever you see a variable, right there, replace it with the cube root of 5x plus 6. So I'm coming up here to g, and where I see that black x, I'm going to replace that with, you have 1/5, replace it with the cube root of 5x plus 6. Do I have anything stuck on here? The minus 6/5. Oh, I think I dropped something accidentally. What did I drop? Yeah, that power of 3. We were going to be stuck if we didn't have that power of 3. Now we know what happens. Cube in a cube root. What happens to the radical? Okay, so, and after we discuss inverse functions, we'll be using that terminology. The inverse function of the cubing function is the cube root function. Look, that cubing function is undoing the impact of that cube root function. Well, anyway, let me continue with the problem. 1/5. Cubing the cube root, we have just a 5x plus 6. Now we can distribute. 1/5 times 5x gives me just 1x, I agree, plus 1/5 times 6 gives me 1/5 times 6 gives me 1/5 times 6. What's that going to give me? No. Remember how you multiply fractions? 1 times 6 is 6. 5 times 1 is 5. So 1/5 times 6 gives me a positive 6/5. And I have a minus 6/5 right here. So what are we going to be left with? Another x. Are they equal? Are the compositions equal? Yes, they are equal. Once again, problems 10 and 11 are just trying to get you ready for the definition of inverse function that we'll be seeing very soon. Two functions are said to be inverses if their compositions reduce to x in both directions. If you take their compositions and everything cancels out except for x, the things are inverses. If you're left with something other than an x, then they're not inverses. Any questions there? So, x. And are they equal? Yes. There are only 13 problems here, and I think 12 and 13, I thought y'all needed to review the cut point method. Now, if you're wondering, isn't that thing ever going to go away? No, not until this class is over. And speaking of which, it is now mid-semester, so we have 8 weeks. This is the end of our 8th week. We have 8 more weeks left. So, I can see the end in sight. Any questions? Okay, then.